index notation and function. Under it, we'll be looking at law of indices, decimal power and base, exponential function. This is powered by Brain Hub Academy by Kenneth Michael. You can always reach out to us on this channel on YouTube. Okay, now topic: index notation and function. Index notation is a method of showing the product of numbers of equal factors or numbers that are the same. So if you have a way you can show the product of equal factors, that's what we call index. Index means power. Okay, look at this, e.g. 2 times 2 times 2 times 2 times 2 is equals to 2 raised to power 5. Why is it 2 raised to power 5? Because we have the 2 are into 5. So generally, if a times a times a times a equals to a raised to power 4, the a is called the base and 4 is the power or index. A is the base, 4 is the power or index. Alright, so this 2 here is the base, this 5 is the power or index. Now, law of indices. Law of indices. The laws: 1. Multiplication law. When numbers with equal base are being multiplied, their product, their power, indices, the power means indices, are added. So if the base, what the law is saying now, if the base are equal, then their power will be added. Take one of the base and add the power. So this is going to be equals to a. The base is the same, so we pick one, which is a. Then the power x and y, we add them, s plus y. That is multiplication laws of indices. Division law of indices, you see, when dividing numbers with equal bases, if their bases are equal, the power of the divisor is subtracted from that of the dividend. All right, now look at it. A raised to power x divided by a raised to power y. Okay, so what it means is that we are going to have is the same thing. This is the same thing as a raised to power s all over a raised to power y. All over means divide. So the base is the same. So pick one of the base, then subtract the power. Okay, the power x minus y, x minus y. Under multiplication is add, but under division you subtract. The next law is power law. If a number which is raised to a certain power is again raised to another power, it is said to be in powers. You see, the powers are now in plural. The power is in plural. Powers. The two powers are thus multiplied together for final result. Now, this is what it means. You see, a raised to power s. This x is index or is a power. And all of them enclosed again, still raised to power of y. So, you see, if you have a setup like this, what you need to do is to multiply the power to make them single power or index. So it's going to be a raised to power s times y, which is xy. A raised to power sy. So we call it power law. Now the next one is a product power law, not product law, product power law. When the product of different factors are raised to a certain power, perhaps in a bracket, the power is distributed over each factor in the bracket. This is what it means. If you have two different bases, this is A and B, they are two different bases, and all of them enclosed in a bracket, all raised to power of a single value. All you did, this power does not only belongs to A or only belongs to B, it belongs to 12. And that's what the law is saying. What it means, if you want to express this further, it means that A will take the power separately, multiplied by B will also take the power separately. So A raised to power s times B raised to power x. We call it product power law. Now we have zero index law. zero index law. Now, when we talk about zero index law, what are we talking about? When any number or quantity is raised to power zero, the result is 1. Look at it. Anything raised to power 0 is 1. That is what the law is saying. A raised to power 0 is equals to 1. 100 raised to power 0 is 1. All right. So the negative index law, the negative index law is saying that a number raised to a negative index equals the reciprocal raised to the same positive index. Now look at what it means. A raised to power of minus 2. What it means is that this is the same thing as finding the reciprocal of this setup, and then the power will become positive. 1 all over, this reciprocal 1 all over, take care of the minus. Then it will be a raised to power 2 instead of a raised to power negative 2. So what can clear this minus is 1 all over, and we call it reciprocal. So it's negative index law. We have power, root power, and fraction index. Root power and fraction index. If you have a raised to power of 1 over 2, this power now is in fraction. So therefore, what it means is that you discover that this first one is a power. So a raised to power 1 is a. See the same thing as a. Then the 2 here will turn to square root, and that is the square root here. Now, to understand it further, if you have a raised to power of this fraction, 2 all over 3, you discover that this 3 now will become the cube root. Cube root. Look at it here. Cube root of a square. Why is it a square? The numerator will form the square or the power, while the denominator will form the root. That is how it is done. We have example 1. Evaluate. Example 1 says evaluate a 3 raised to power 2 times 3 raised to power 5. By men looking at this, which law do you think will go for us? B is 2 raised to power 9 divided by 2 raised to power 6. We also have C, 2 raised to power 3, all in bracket, raised to power 2. D, 2 raised to power 5 minus divided by 2 raised to power 5. Then E, 2 raised to power 6 divided by 2 raised to power 9. And then F, 9 raised to power half. And then G, 4 raised to power 5 over 2. Now solution, 3 raised to power minus 2 times 3 raised to power 5 is the same thing as, this is product law. Pick one of the base is the same, then add the power. 3 raised to power 2 plus 5, which is 3 raised to power 2 plus 5 is 7. Then this is division law. You are dividing. This is a division law, will help us here. So pick one of the base, all right, and subtract the power. What it means, that is what it means. 2 raised to power 9 minus 6, which is 2 raised to power 9 minus 6 is 3. All right, so the next one, this one, all right, 2 raised to power 3, all in bracket, multiplied by 2. Of course, the law that will help us here says that all we need to do is to ensure that we have 2, these 2, pardon this, mistake. This is handwritten. This 3, this base, which is 3 here, is supposed to be 2. Okay, so it's 2. This is 2. Please look at my arrow there. It's 2, not 3, please. It's 2 raised to power of what? 3 times 2. 3 times 2. So 3 times 2. So this is 2. Please treat this as 2 is 2, not 3, please. Thank you. 2 raised to power 6, because 3 times 2 here is 6. Then we also have 2 raised to power 5, divided by 2 raised to power 5. So you are going to see subtract. 2, pick one of the base, since it's the same, subtract the power. 2 raised to power 5 minus 5. 5 minus 5 is 0. 2 raised to power 0. We can't stop here, because any number raised to power 0 is what? Is 1. All right, so the next one is 2 raised to power 6 divided by 2 raised to power 9. You see, if you do this, it's going to be pick one of the base, subtract the power, 6 minus 9. 6 minus 9 will give us minus 3. And minus 3, of course, this is reciprocal now. This minus means 1 all over, then 2 raised to the power 3, which is equals to 1 all over 2 raised to the power 3 is 8. Then 9 raised to the power 1 over 2. Alright, this denominator form the root. So it's going to be 9 raised to the power of 1, so root of 9. 9 raised to the power of 1 is 9. Root of 9 is, square root of 9 is 3. The last example, the last one here, now example 1, 4 raised to the power 5 over 2. Of course, the denominator form the square root, while the numerator, which is 5, they form the square, the power, or rather the power. So this is going to be square root of 4, and then all of them in the power of 5. Square root of 4 is 2. If square root of 4 is 2, then power of 5 is what we put here. 2 raised to the power 5 is 32. Okay, so we have example 2. So we should simplify 16. Simplify 16 over 81, all raised to the power 3 over 4. Okay, so if you have this, and then look at another example again, let's solve, and this is the third example. Let's solve them one after the other. 16 over 81, all raised to the power minus 3 over 4. This is the same thing as this minus. This minus means 1 all over. That's why we have 1 all over. 16 over what? 81. 16 over 81 raised to the power 3 over 4. No more minus. We have removed the minus. The minus have been taken care of, 1 all over. So this is the same thing as, you see, this thing is the same thing as, 81 all over 16. Why is it 81 over 16? It is 81 over 16 because of what we call inverse multiplication. This 1 all over, by the time you interact it with this fraction, the denominator of this fraction will go up, the numerator will come down. All of them is c raised to the power 3 over 4. So we are going to have, what we have here is 4. If you don't know how this thing happened, you can chat me up. Chat me up. Look for my number. Is there. Chat me up on WhatsApp and I will explain further. Alright, so here, what we have here is, of course, this is going to be fourth root of this, and then all of them to the power of 3. See, fourth root of 8 over 81 over 16, all of them to the power of 3. Fourth root of 81 is 3. Fourth root of 81 is 3, and then fourth root of 16 is 2. Okay, your assignment is, how do you find fourth root? All right, find it out. It's a little assignment. Then 3 over 4, 3 over 2, all raised to the power of 3. 3 raised to the power 3 is 27, and 2 raised to the power of 3 is 8. Then the B part, we have all of this. If we have all of this, all of them is in the square root. So the law, division law, will help us. That 245 divided by 5 will give us 49. 49. P is here, P raised to the power 3 is here, P raised to the power 5. So they are base number, they are base alphabet. So we can pick one of them. Alright, so we pick one of the P. Then you have it 3, the power is 3 here, minus the power is 5. That is what we have here. Then we pick Q. Q is this. Then the power of it is minus 2. Then we have minus 6. Because the division law will give us extra minus, so that minus this 6 will give us plus 6. So this is going to be square root of 49. P raised to the power 3 minus 5 is minus 2. Then Q minus 2 plus 6 is 4. So square root of 49 is 7. Square root of 2 of this P raised to the power minus 2, the square root will cancel the 2. We are left with what? With minus 1. Then you have square root of 4, Q raised to the power 4 is going to be Q square. Alright. Then this is going to be equals to 7 multiplied by Q, because Q here is raised to the power positive 2. But P has negative 1, and negative means 1 all over. So this thing is the same thing as 7q raised to the power 2 times 1 all over p, which will give us 7q square all over p. The next one is 16 raised to the power this fraction 3 over 4 times 4 raised to the power 1 over 2 all over 8 raised to the power 5 over 3. So this is going to be equals to here the fourth root of 16 to the power of 3, fourth root of 16 to the power of 3 times square root of 4 to the power of 1, square root of 4 to the power of 1 all over third cube root of 8 to the power of 5, cube root of 8 to the power of 5. So this is going to be fourth root of 16 is 2, which is to get anything fourth root, 5 root, what? Okay, example, if you want to get this, for if you have your calculator there, press with me. What you are going to press is 4, then shift, then there is a power, there is a symbol for power, inverted V on your calculator, inverted V. Press it, then press 16. You discover that you get 2. Okay, then times square root of 4 is 2 all over cube root of 8 is 2, then raised to the power of what? 5. So 2 raised to the power 3 times these 2, both of them are the same. You see, 2 and 2, they are the same. This 2 here, the power of it is 1, but we don't need to put it. So pick one of the base, add the power according to product law. 3 plus the invisible one here. That is what we have here, all over 2 raised to the power 5. So this is the same thing as 2 raised to the power 4. 3 plus 1 is 4, all over 2 raised to the power 5. Then what we have next now is two of them is the same. This is division law. Now using this division law, pick one of the base, subtract the power. 4 minus 5, 4 minus 5. This is going to be equals to 4 minus 5 is minus 1, 2 raised to the power minus 1, which is going to be equal to this minus, this is reciprocal now. This minus this, the same thing as 1 all over. Then 2 raised to the power 1 is still 2. So the answer is half. Alright, so that is what we have there.